This video is on evaluating trig expressions with the angles in radians. So the first problem says the 2 cosecant of pi over 6 plus 3 cotangent 5 pi over 6, and this is question 2b from the recent homework assignment. So pi over 6 is 1/6 of the way to pi, so we want to draw a triangle in the first quadrant because 1/6 of the way to pi is in the first quadrant with a 30-degree reference angle. So it looks about like that. And then we can label the sides of the special right triangle with 1, 2, root 3. And everything is positive in that quadrant. And you might want to label an ordered pair here right on the circle to make sure that you think about whether the x and y coordinates are positive or negative. So this problem is 2 times the cosecant of pi over 6. So cosecant is r over y, so I need the radius over the y coordinate. Plus 3 times the cotangent of 5 pi over 6. So 5/6 of the way to pi is another right triangle. And this time the sides, it's also a 30, 60, 90 special right triangle, so the sides are 1, 2, root 3. But this time you have to remember that the root 3 is negative. Second quadrant, left root 3 and up 1. And labeling this point is a very good idea. Left negative root 3 and up 1. I could have done that here too, but since it was in the first quadrant, I was a little lazy about that. So now it's the cotangent of 5 pi over 6, and cotangent is x over y. So I'm going to take the x coordinate, negative root 3, and put that over the y coordinate, which is 1. And then simplify that expression. So it is 4 minus 3 root 3. Next we have 2 secant squared of 5 pi over 3. Now this squared notation you might not have seen before. It just means the expression is really going to be 3 secant of 5 pi over 3, and then that value is squared. So first we need to find the angle 5 pi over 3, which is more than pi. It's 1 2/3 pi. So 1 pi is here, 1/3 more would be here, and 2/3 more would be here. So it is a tall triangle in the fourth quadrant. And the sides, again, are the special right triangle with a 30, 60, 90. So 1, 2, root 3. And the root 3 is negative because we're in the fourth quadrant. So the point there is over 1 and down root 3. So then this is 3 times whatever we get for the secant, and then we'll square it. So secant is r over x, radius over x coordinate. So 2 over 1, so it's 3 times 2 squared, or 3 times 4, which is 12. Okay, moving on to this problem was 3a on the assignment, and we are supposed to substitute in theta equals 5 pi over 12 into this expression, and then do another problem with theta equal pi over 6 into the theta variable here and figure out that value. So it's really 2 problems in disguise. So the first one, before I draw the angle, I want to substitute it in. So it's 3 times 5 pi over 12. That's 3 over 1. So order of operations, I need to do parentheses first, which is why I don't want to try and draw 5 pi over 12. And if I did draw 5 pi over 12, it is not a special right triangle, and I would be kind of stuck in trying to figure it out. So this will be 15 pi over 12, or if I cross-cancel the 3 into the 12, it will simplify more quickly to 5 pi over 4. So 5 pi over 4 is 1 1/4 pi. So that means that I want to go to pi, but then a quarter of pi more. So that's going to be right in the middle and in the third quadrant. Remember that it's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So that's a 45, 45, 90, which is a 1, 1, root 2. So I need a negative and a negative. So the ordered pair here, if it wasn't so squishy, I would write it in left 1, down 1. So negative 1, comma negative 1. So then this is 2 plus 4 times the sine of 5 pi over 4. Sine is y over x. Y over r. So you get negative 1 over root 2. Or 2 plus 4 multiplying negative root 2 over 2 if you rationalize. And so this is 2 minus 4 root 2 over 2, or 2 minus 2 root 2. And then for the second part of the same problem, now I'm going to take this same expression and substitute in theta equals pi over 6. Separate that out. So now it will be 2 plus 4 sine of 3 multiplying pi over 6, which simplifies to 2 plus 4 sine of pi over 2. 3 times pi over 6 is pi over 2. And then I need to find the sine of pi over 2. So pi over 2 is half of the way to pi. So if this is pi, then pi over 2 is up here at the top. Now there's no triangle to draw when the point falls right on the axes. So you just have to decide on a radius for your circle. Remember the radius of the circle doesn't matter. So I'm just going to choose 1. And if the radius of this circle is 1, then this ordered pair is over 0 and up the same amount as the radius. So x comma y, and there's the radius. Sine is y over r. So y over r is 1 over 1. And that's 2 plus 4, which is 6. Alright, so 4b has pi plus pi over 4k, and it's just asking you to find the sequence setting k equal to 0, and then k equal to 1, and 2, and 3. So if I do pi plus pi over 4 0 times, well, that just equals pi. The next one gets a little more interesting. Pi plus pi over 4 one time. So that equals 4 pi over 4 plus pi over 4, or 5 pi over 4. And then the next one is pi plus pi over 4 twice. And so I know that this is going to need to be 2 pi over 2 because I'm kind of looking ahead and seeing that double pi over 4 is really pi over 2. That's because this is really 2 over 1, and 2 pi over 4 simplifies to pi over 2. So now if I add those, I get 3 pi over 2. And then the last one is pi plus pi over 4 times 3. So that equals 4 pi over 4 plus 3 pi over 4, which is 7 pi over 4. So this is my answer here. Pi over 4, 3 pi over 4, I'm sorry, pi over 4, 5 pi over 4, 3 pi over 2, and 7 pi over 4. Now hopefully that makes sense, and you can see this here. It's saying pi plus pi over 4, a quarter of the way to pi, so that's here. And then plus another pi over 4 would be here, plus another pi over 4 would be here. So that's pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. I think it's nice to think of it that way. Alright, last one is to draw the angle in standard position, 3/4 of the way to pi. It's right here. Identify the reference angle. That's between this angle, this terminal side, and the x-axis. That theta reference in radians is pi over 4, and in degrees is 45 degrees. I would say right now it's nice to do both of these, but in general, when you use this skill of finding this angle, you're usually doing problems like these, and I think it's fine to think of these angles in degrees. But for good practice, doing both is a good idea. Okay, then we need angles that land in this same place. So all you need to do to find those is add 2 pi to 3 pi over 4, then add 2 pi again, add 2 pi again. You could keep doing that over and over and over again, or you could subtract 2 pi. So if you add 2 pi, you'll be at 3 pi over 4. And if you add 2 pi, you will go from here this direction. So that would be 3 pi over 4 plus 2 pi. We can say 2 pi over 1. So that will be 3 pi over 4 plus 8 pi over 4, or 11 pi over 4. So that's one of the coterminal angles. And then if you did the same thing again, except for you subtracted 2 pi, it would be 3 pi over 4 minus 8 pi over 4. So another coterminal angle would be, let me switch colors on that. Another coterminal angle would be 3 pi over 4 minus 8 pi over 4, or negative 5 pi over 4. And that would be starting at 3 pi over 4 and going this way, 2 pi radians. And if you wanted to make sure those are right, remember you could count off pi over 4s. So the divisions of pi over 4 would be kind of where these yellow lines are and this blue line. So if you went negative 5 pi over 4, that would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So clearly that's coterminal with the blue line. And if you went in the positive direction all the way around and back here again, that would be 11 pi over 4. So it would be 1, 2, 3, 4 pi over 4, 5 pi over 4, 6, 7, 8, 9, 10, 11 pi over 4. So you can kind of do a little quick check to make sure that those do in fact lie in the same place.